for our assumptions, we assume that the beam weights are neglected. Loads are only on the vertical axis. The B roller are also vertical, and f of x equal to ax, which is equal to 0, which means no horizontal forces.
So next we're going to find our knowns and unknowns. Up here we have all the things we know and given in our problem. We'll start with our beam length, which goes hand in hand with the distances of the load. So we have 30 inches for AX1 and then 30 inches plus 50 inches for AX2. Next we have our support types, which will help us find out how we're going to use our equations. For A, we're using a pin support, and for B, a roller support. And then our applied loads, which tells us how much weight is being added to the beam, is 800 pounds and 1,600 pounds as well. At the end of the equation, after we solve the problem, we'll be finding AX and AY as well as BY.
Coming up next is a real world connection of our problem with a real life. So this is a beam structure with a pin and roller support, very common for the design process of bridges. So an example of which would be this one right here. So the pin support, which is represented by A here, allows it to handle loads, while the roller supports allow in order for the bridge to handle changes in temperature and adapt and minimize damage done to it. And well, the values of 800 and 1,600 pounds represent the loads that the bridge can handle. So for instance, if we have let's say cars or trucks coming along there, that's the value that is represented here. And the distance, well, is how long the bridge is, and the unknown values that we have to find, that represents the forces exerted by the beam supports. So in this case would be the pin A and the roller B.
So for this problem, we're going to be analyzing a simple support beam that has two forces being applied downwards, which is going to be 800 pounds and 1,600 pounds. The beam is going to be 120 inches long. We're going to be using the pin at A, which is on the left side, as our reference, and we also have a roller at the right side as B, which is only having an upward force. A is going to be having horizontal and upward reactions. So for A, we're going to be finding out how the beam reacts to a force of 800 pounds being applied downwards, 30 inches away from pin A, and then we're going to have 1,600 pounds being applied on the beam, which is going to be 8 inches applied from the left side of A. We're going to be implementing these three equations, which is going to be the summation of the forces at X, which are going to be equal to 0, the summation of forces at Y, which is going to be equal to 0, and then the momentum, which we're also going to set up at 0. We're going to be finding the values, plugging them into this equation so we can find the momentum and then the forces at A.
So, as we established with this problem, we're going to have two summation forces. We're going to have the force in the Y direction, and we're going to have the force in the X direction. Since we already established that point B is going to be a roller reaction, we know that there's not going to be any kind of X force for point B. So the only X force for this entire beam is going to be at point A, which means that the summation of the forces in the X direction is just going to be equal to A of X. And since the entire beam is at equilibrium, that means that A of X has to be equal to 0. Now we can turn our attention to the forces in the Y direction. As we established with the diagram, we know that there's going to be four forces: an upwards force at A downwards force of negative 800 pounds, a downwards force of negative 1,600 pounds, and an upwards force at B. We can rewrite this as A of Y plus B of Y minus 800 minus 1,600 is equal to 0 to show that the beam is at equilibrium. We can move this negative 800 and this negative 1,600 over to the other side, and we get A of Y plus B of Y is equal to 2,400, which means that the forces in the Y direction for A and B have to be equal to 2,400 pounds. We also stated that we're going to be using A as our point of reference, which means that we can set the summation of the moment at A equal to 0, since the entire beam is at equilibrium. Now we need to find how much exact force is being applied at each interval that we're measuring at 30 inches, at 80 inches, and at 120 inches. So since there is an 800 pound force being applied at 30 inches, we can rewrite that as negative 800 pounds times 30 inches. There's a 1,600 pounds downward force being applied at 80 inches, so we can rewrite that as negative 1,600 pounds times 80 inches. and there is some B of Y force being applied at 120 inches, which is across the whole beam. So we can rewrite that as B of Y times 120. We can set all of this equal to 0. Now we simplify all of these numbers. We get negative 24,000 pounds times inch minus 128,000 pounds times inch plus 120 by pounds times inch is equal to 0. We can move the two constants over to the other side, and we get 120 by pounds times inch is equal to 152,000 pounds times inch. Now we can divide out 120 inches on both sides. We cancel the 120 on the left, and we cancel the inches measurement on both sides, and we get by is equal to 1,266.67 pounds, which means that there is 1,266.67 pounds of force being applied upwards at point B. Now we can plug this number back into A of Y plus BY is equal to 2,400 to get A of Y plus 1,266.67 is equal to 2,400. Subtract on both sides, and we get A of Y is equal to 1,133.33 pounds, which means that there's 1,133.33 pounds of force being applied upwards at point A.
Alright, so in the previous part, we found that the AY and BY were both equal to 2,400. So we know that the total forces are supposed to equal to 0. Therefore, we got that AY plus BY minus 800 and minus 1,600, because these are the two forces that are applied downward on the line, as we can see, right? So that should equal to 0. And if we plug in the numbers that we got and subtract the 2,400 pounds applied to it, that should equal to 0. So we got that part. And so we'll be moving on to the verification of momentum about point A. So we know that 800 pounds was applied at 30 inches, and that's from point A. And we know that 1,600 pounds was applied on 80, yeah, that's 80 inches from A. And so if you multiply that together, you will get you will get 24,000 and 128,000. And so when you add them together, you get 152,000. And we know that BY is equal to 1,266.67. We plug that in, and we get 152,000, which was the answer that we were looking for.